Hey everybody, we're here today for this video to talk about insulation testing, a little bit about what loss of insulation is, a little bit about the Fluke 1587 and how to use it for loss of insulation diagnostics. So first things first, what is loss of insulation? Loss of insulation means that at least in our hybrid EV high voltage type scenarios, we're dealing with a scenario where we don't have insulation where we should, or electricity or voltage is jumping to somewhere where it should not. So what we're going to use today to test this is a Fluke 1587 FC meter. FC is for your Fluke Connect. But what's really snazzy about a 1587, because I know a lot of it looks very similar to the average DVOM that Fluke makes, it is that it has an insulation tester included inside of it. Now, what that means is that all meters have a power source inside to produce a small amount of current for ohm testing and things like that. This one has the capability of producing a lot of voltage, very, very low current, but high voltage, 500 up to 1,000 volts. Is what this meter can produce, and that's actually what we're doing when we use the insulation tester in that mode. So I've got a couple of cables here that we're going to test their insulation, and then we also have a stator from a motor that we're going to test, and I'll show you how and what we're going to do that so for our cables, first it's important to note that our hybrid cables are not the same as any other wire. They have multiple layers of insulation. So if this sort of black hollow area here is our actual cable that carries voltage and current, we have 1, 2, and 3 layers of insulation. We've got one that you can't see, this sort of green layer inside. The middle layer here that I have in blue, it actually has this looks sort of like a shadow, but it's actually a metal eyelet that insulation is attached to. So if we're looking at this here, this section here that has a little eyelet here on it, that is our blue insulation in the picture. And then on the outside, we've got our orange conduit that is also protecting it. So what we're going to do is test the essentially continuity between our actual cable or conductor and the insulation outside of it. We really shouldn't be seeing anything since there is another layer of insulation in between that. The whole reason for this test is we don't want any really high voltage leaking to a chassis ground where it could be dangerous for the driver or any passengers in the vehicle. So our vehicle would eventually see this, it would throw a code and keep the vehicle from turning on. What you'd have to do is you'd have to check the code on it. It may not tell you where it's at. I have another hybrid video that you guys probably have already watched a little bit on that, on how to figure out where you should be looking. But once you found the area and isolated it, this is how we're going to perform the loss of insulation test. So back to our meter here. First things first, I'm going to hook up our cables. But before I do that, I want to talk a little bit about them. So we have our regular meter leads that we can hook up and use for the insulation test. Right now, they don't carry the caps on them. So they do lower down on their cap level protection. And then we also have a third one that our 1587 comes with that it's going to need to plug into the special connector here. What's really cool about this lead is it has a button. So I can either engage the tester via this button or this orange button here on the tester. And when I press on that button, it's going to send out a high voltage to test for an isolation fault. Another cool thing that this meter comes with is these set of alligator clips. So if I don't want my hands anywhere near 1,000 volts, because it's not going to kill you, it's very, very low current, not dangerous at all, but it is going to hurt. You'll feel it a little bit. So what we're going to do is utilize the alligator clips and utilize the lead with the button so we don't really have to have our hand on anything. So we'll go ahead and hook up our ground to the appropriate side. I know this is a red hole here, a red terminal, but if you look here, how we're going to set our meter up for an insulation test is going to be via our knob here. And on the knob in orange, it's showing that we can go all the way from 50 volts to 1,000 volts, depending on the application. However, it's going to need our leads to be plugged in where our orange indicators are there. So we'll go ahead and hook up our red lead there. We'll go ahead and hook up our black lead there. What I'm going to do is try to keep that standing here without, I may not be able to do that. I'm going to go ahead and hook up our black alligator clip to, if it doesn't want to, oh, there we go, to our negative lead there. And now we're all hooked up, ready to go. Over back to our tester here. Down at the bottom, it says 1,000 volts. I can change that. So right here, it says test voltage. I can go from 50, 100, 250, to 500, to 1,000. You're going to want to test at above whatever the range that your vehicle runs at. So if I've got a 500 volt battery, then I should be using 1,000 volts to test, because our peak voltages maybe could possibly be higher. If I'm running a 250 volt battery, then 500 should be just fine. Right now we'll go ahead and leave it at 1,000 because it's fun. So looking at our cables here, I've got two here. One of them is going to be good while the other one is going to test bad. We don't know which one yet. To make this nice and easy, we're going to go ahead and hook up our alligator clip to the insulation that I drew earlier with the eyelet. And then we're going to take our tester, try to not do this around the meter here. I'm going to take our tester here, I'll put this back here, and I'm going to touch the metal conductor on our cable, and I'm going to press my button here for 2 seconds. You can hear it. And it says right now that I've got, oops, 0 ohms. Or 0 mega ohms, 0 ohms regardless. That tells me that I have no resistance in between my conductor and my outer insulation. That is a problem. That is absolutely a loss of insulation. That would definitely throw a code on this vehicle. What a good cable might look like is, let's go ahead and hook our alligator clip up here, something like this. We'll do the same test. Hold our button for 2 seconds. And we've got 2.2 giga ohms, which is actually as high as the meter will go. It's as close to infinity as this meter goes. So that means that this cable is in fact okay, while this cable has a loss of insulation. If I wanted to do the same test on a motor, because it's actually common for the motor windings to short to the case. Electrically, I have 3 separate connections here. And what we're looking at, if you look at the whiteboard here, are windings. So each one of those connections is going to connect to its own winding. However, for an insulation test, you only need to test one of these. Because if I have a loss of insulation on any one of these, it will show up. So if I have a loss of insulation here, I could test here and it will show, I could test here and it will show, and I can test here and it will show. So what's really nice about this one is that I only need to test one of the windings in order to test the whole motor. I don't need to test all 3. If you were testing something like a power inverter, you would need to test all 3. But just because of the way the stator windings are wired up, we only need to test one of them. This is what it would look like coming out of the stator case, or the whole motor case, because you won't be looking at this. This one's actually quite obvious. We'll show you in a moment. These connections would have cables coming out of a metal case. We would unhook those cables and we would test them. So for the sake of things right now, we're going to go ahead and test these. I'm going to use my alligator clip here. And we're going to test to our stator core or stator case, because if you look inside here, there should be some insulation. There's insulation around these wires, even though it doesn't look like it. And there is insulation in between here through our laminations. So there should be no continuity between these. So I've got it hooked up to one of my leads here. And we're going to go ahead and test to the case. And we've got 0 ohms. Now, this should be the same theoretically on all of them, right? So if we were going to test that, we could test each one of these. And each one of them will show 0 ohms, because as the same point I was talking about earlier, it doesn't matter if one of them is grounded. They all are going to be grounded. And you can see right here where that happened. It really sort of burned through, because again, there's a lot of current going through here, a lot of heat. So loss of insulation on a stator winding is usually visible or quite visible. So that's how you perform a loss of insulation test on an electric motor or on any of your high voltage cables. Thanks, guys.